The universe is a vast and mysterious place, filled with wonders and secrets waiting to be discovered. For centuries, we've gazed at the stars and wondered about our place among them, seeking answers to the fundamental questions of existence. We've strived to understand the fundamental laws governing the cosmos, using mathematics and science as our guides. Today, we stand on the precipice of a new era of discovery, an era powered by a revolutionary technology, quantum computing, which promises to transform our understanding of the universe. Imagine a computer so powerful that it could unlock the secrets of the universe, revealing insights that were once beyond our reach. Imagine a computer that could simulate the complex interactions of molecules, leading to the development of life-saving drugs and groundbreaking medical treatments. Imagine a computer that could break the codes that protect our most sensitive information, while simultaneously creating new, unbreakable codes to safeguard our data. This is the promise of quantum computing, a technology that harnesses the bizarre and counterintuitive laws of quantum mechanics to perform calculations that are impossible for even the most powerful classical computers, opening new frontiers in science and technology. But quantum computing is not just about solving complex equations, it's about exploring new realms of possibility. It's about pushing the boundaries of human knowledge and understanding, venturing into the unknown with curiosity and determination. It's about unlocking the secrets of the universe and using that knowledge to improve our lives in countless ways, from enhancing technology to solving global challenges. For decades, classical computers have served us well, processing information as bits, represented as zeros and ones, like tiny switches flipping on and off. These bits are the fundamental building blocks of classical computing, enabling everything from simple calculations to complex algorithms. But this binary system has limitations. As we push the boundaries of technology, we encounter problems that classical computers struggle to solve efficiently. It struggles to handle problems involving vast numbers of variables or simulate the complexities of the natural world. Tasks like modeling molecular structures or optimizing large-scale systems become increasingly difficult. This is where quantum computing takes a giant leap forward. By harnessing the principles of quantum mechanics, we can overcome these limitations. Instead of bits, quantum computers use qubits. These qubits are not limited to binary states. Imagine a qubit not as a switch, but as a dimmer, capable of existing in a state of both 0 and 1 simultaneously. This ability to be in multiple states at once is a game changer. This mind-bending concept is called superposition. It allows quantum computers to process a vast amount of information simultaneously. Now picture two of these dimmer switches, inextricably linked. This linkage is not just a theoretical idea, but a practical feature of quantum systems. Adjusting one instantly affects the other, regardless of the distance between them. This phenomenon is known as quantum entanglement. This is entanglement, another cornerstone of quantum mechanics. It enables quantum computers to solve complex problems more efficiently. These unique properties of superposition and entanglement allow quantum computers to perform multiple calculations at once, exponentially increasing their processing power. This parallelism is what sets quantum computing apart. It's like exploring a maze with a million flashlights, illuminating every path simultaneously, instead of taking one step at a time. This revolutionary approach opens up new possibilities for solving some of the world's most challenging problems. Imagine a vast library filled with every book ever written, and you're searching for one specific piece of information. In a traditional library, this could take hours, days, or even weeks. A classical computer would be like searching each book, one by one, until it finds the right answer. This method is time-consuming and inefficient. Quantum computing is different. It's like whispering your question in the library, and every book simultaneously responds with the relevant information. This is a revolutionary approach. This is possible because of superposition, where qubits exist in multiple states at once, allowing for massive parallel processing. Imagine being able to read all the books at the same time. But how do we make sense of all these simultaneous answers? It seems chaotic, but there's a method to the madness. This is where quantum interference comes in. It helps to sort through the chaos, like waves on a pond. Quantum states can interfere with each other, amplifying the correct solutions and canceling out the incorrect ones. This process is crucial for finding the right answer. Think of it like tuning a radio. You need to find the right frequency. You turn the dial until the signal becomes clear, filtering out the static. This is similar to how quantum interference works. Quantum interference does the same thing, refining the results until the most accurate solution emerges. This is the power of quantum computing, transforming how we solve complex problems. The heart of a quantum computer is the quantum processor. These processors are delicate, intricate devices, often kept at temperatures colder than the vacuum of space to maintain the fragile quantum states of the qubits. Google's Sycamore processor, for example, achieved a milestone in 2019 by performing a calculation in just 200 seconds that would have taken a classical supercomputer thousands of years. This event marked a turning point, demonstrating the potential of quantum computing to outperform classical computers for specific tasks. But the development of quantum computers is an ongoing journey. Researchers around the world are constantly working to improve the stability and reliability of qubits, build larger and more powerful processors, and develop new quantum algorithms. Section 5. Reshaping reality. Quantum computing's impact on various fields. The potential applications of quantum computing are as vast as the universe itself. In healthcare, imagine a future where we can design personalized treatments tailored to an individual's genetic makeup, or develop new drugs and therapies at an unprecedented pace. In finance, quantum computers could revolutionize investment strategies, optimizing portfolios with incredible precision and speed, or identifying fraudulent activities with unparalleled accuracy. Artificial intelligence stands to benefit immensely from quantum computing. Imagine training complex AI models in a fraction of the time, leading to breakthroughs in natural language processing, image recognition, and autonomous systems. Even the fight against climate change could be aided by quantum computing. By simulating complex climate models, we can gain a deeper understanding of our planet's interconnected systems and develop more effective solutions to combat global warming. Section 6. Quantum for all benefits across different domains. The quantum revolution is not just for scientists and engineers. It holds the potential to benefit people from all walks of life. For developers, learning quantum programming languages like Google's Cirq or IBM's Qiskit opens up a world of possibilities to create innovative applications. Businesses can leverage quantum computing to optimize their operations, whether it's improving logistics, designing more efficient energy grids, or developing new materials with revolutionary properties. Researchers in various fields can harness the power of quantum simulation to tackle some of the most challenging scientific problems, from understanding the fundamental nature of matter to unlocking the secrets of the human brain. Even if you're not a scientist or engineer, staying informed about quantum computing is crucial. This technology will undoubtedly shape the future, and understanding its implications will be essential for informed decision-making in the years to come. Section 7. Shaping the Quantum Future: Education, Ethics, and Collaboration. As we venture further into the quantum realm, it's crucial to remember that with great power comes great responsibility. Educating the next generation about quantum computing is paramount, ensuring that they possess the skills and knowledge to navigate this transformative technology. Ethical considerations must be at the forefront of quantum computing development. We need to establish guidelines for responsible use, particularly in areas like artificial intelligence, where bias and fairness are critical concerns. Collaboration is key to unlocking the full potential of quantum computing. Governments, research institutions, and private companies must work together, sharing knowledge and resources to drive innovation and address the challenges that lie ahead. Section 8. The Quantum Horizon. A future brimming with possibilities. The quantum horizon beckons, filled with potential breakthroughs that could reshape our world. Imagine a future where diseases are eradicated, climate change is reversed, and the mysteries of the universe are unveiled. While quantum computing is still in its early stages, its potential to revolutionize countless industries is undeniable. From healthcare and finance to material science and artificial intelligence, the possibilities are truly limitless. But the true power of quantum computing lies not just in its ability to solve complex problems, but in its potential to inspire a new generation of thinkers, dreamers, and innovators. It's a call to explore the unknown, to push the boundaries of human ingenuity, and to create a future that surpasses our wildest imaginations. Section 9. Join the quantum revolution. The quantum revolution is not a distant event, it's happening now. The journey of exploration has already begun, and we invite you to be a part of it. Learn more about quantum computing, explore the resources available online, and discover how you can contribute to this exciting field. The future is uncertain, but one thing is clear. Quantum computing has the potential to change the world as we know it. Let's embrace this transformative technology with open minds and a shared commitment to shaping a brighter future for all. The quantum revolution is here. Are you ready to join? Then you for watching, share, like, and subscribe to learn more and ruin your curiosity.